Today we are going to learn about building real-time APIs with FastAPI and WebSockets. You'll gain the skills to set up WebSocket connections in FastAPI, enabling real-time communication for interactive user experiences.
Welcome to our video on building real-time APIs with FastAPI and WebSockets. As digital interactions proliferate, real-time communication has become a cornerstone for creating dynamic and engaging user experiences. WebSockets provide a robust protocol for facilitating real-time data exchange, making them a crucial component in modern web applications. In this video, we'll explore how FastAPI, a modern web framework, supports WebSocket integration to deliver live data updates efficiently. We'll guide you through practical steps to set up WebSocket connections, manage client interactions, and ensure secure and scalable implementations. By the end of this session, you'll have a comprehensive understanding of using FastAPI and WebSockets to build responsive applications.
WebSockets are a powerful protocol designed for real-time communication. Unlike traditional HTTP, which follows a request-response cycle, WebSockets establish a persistent connection between the client and the server. This allows for bidirectional data exchange, meaning both the client and server can send messages to each other independently. This capability is crucial for applications requiring real-time updates, such as chat applications, live notifications, or collaborative tools. Imagine a stock trading platform where prices need to be updated instantaneously. WebSockets are ideal for such scenarios. By maintaining an open connection, WebSockets reduce the overhead of constantly establishing new connections, thus enhancing performance and speed. Throughout this video, we'll demonstrate how to leverage WebSockets to create seamless and interactive user experiences. Before diving into WebSocket implementation, it's essential to set up FastAPI, a modern, fast web framework for building APIs with Python 3.7+ based on standard Python type hints. To get started, we'll first install FastAPI and Unicorn, a lightning-fast ASCII server for serving FastAPI applications. Open your terminal and run the command pip install FastAPI Unicorn. Once installation is complete, we'll create a basic FastAPI application by defining our app instance. Here's a simple example. From FastAPI import FastAPI, app equals FastAPI. Now, let's configure our application to support WebSockets. FastAPI natively supports WebSockets, so integrating them becomes straightforward. We'll discuss how to set up a WebSocket route and run our FastAPI server using Unicorn. Simply execute Unicorn main app reload to start your server. This setup forms the foundation for all subsequent WebSocket-related development. Creating a WebSocket endpoint in FastAPI is a straightforward process. First, we need to define a route specifically for WebSocket connections. In FastAPI, this can be done using the WebSocket class. Here's an example of how to set up a basic WebSocket endpoint at app.websocket/ws. Inside this route, we'll handle client connections and manage the data flow. When a client connects, the server can read messages using await WebSocket.receive_text and send messages back using await WebSocket.send_text. These functions allow for real-time, two-way communication with clients. It's essential to ensure that our WebSocket endpoint can handle various message types and manage different client states. Testing is crucial at this stage. By using tools like Postman or WebSocket testing clients, we can simulate connections and ensure our endpoint behaves as expected. This block lays the foundation for more complex interactions and is an integral step in building real-time applications.
Managing WebSocket connections and disconnections effectively is crucial for maintaining application stability and performance. When a client connects to our WebSocket endpoint, we first authenticate or validate the connection if necessary. Once authenticated, the connection is established, allowing the client to send and receive messages. But what happens when a client disconnects? We need to handle such scenarios gracefully to ensure resources are freed appropriately. FastAPI provides mechanisms to detect disconnections, allowing us to clean up any client-specific state or data. Additionally, error handling is vital. We must anticipate and manage potential errors, such as unexpected disconnections or data transmission issues. Implementing robust error handling ensures our application remains resilient under various conditions. State management is another critical aspect, especially when dealing with multiple clients. We need to track and manage each client's state to provide consistent and reliable service. By effectively handling connections and disconnections, we ensure a smooth and efficient user experience.
Broadcasting messages to multiple clients is a powerful feature of WebSockets, enabling real-time updates across numerous users simultaneously. In FastAPI, we can maintain a list of active connections and iterate over this list to send messages to every connected client. This is particularly useful in scenarios like live sports updates or collaborative applications where changes need to be reflected instantly to all participants. Efficient broadcasting requires us to manage the list of clients carefully, adding new connections and removing those that have disconnected. A scalable implementation is essential as the number of clients grows. Techniques such as sharding or load balancing can be employed to distribute the load evenly. Real-world use cases of broadcasting include live auctions, multiplayer games, and real-time analytics dashboards. By efficiently managing and broadcasting messages, we can create applications that provide users with immediate and relevant information, enhancing the overall experience.
Integrating WebSockets with front-end applications is a crucial step in creating interactive user interfaces. The JavaScript WebSocket API provides a straightforward way to establish WebSocket connections from the client side. By creating a new WebSocket instance, we can connect to our FastAPI server and start sending and receiving messages. Handling WebSocket events such as onOpen and message and onClose enables us to manage the connection lifecycle effectively. Once connected, we can update the UI in real time based on the data received. This is particularly useful in applications that require immediate feedback or updates, such as chat applications or live data feeds. Ensuring cross-platform compatibility is also vital, as users may access applications from various devices and browsers. By integrating WebSockets with front-end technologies, we can deliver seamless and responsive user experiences that keep users engaged and informed.
Security is a critical aspect of implementing WebSockets in any application. Ensuring that connections are authenticated and authorized is the first step in protecting user data and maintaining application integrity. We can implement authentication tokens or session-based authentication to verify users before establishing a WebSocket connection. Data encryption is equally important, especially when transmitting sensitive information. Using Secure WebSocket, WSS:// ensures that data is encrypted during transmission, protecting it from eavesdroppers. Additionally, we must protect our application against common WebSocket attacks, such as cross-site WebSocket hijacking or denial of service (DOS) attacks, by implementing appropriate security measures. Secure connection handling involves regularly checking and validating the connections, closing any suspicious or inactive connections to prevent misuse. Following these best practices ensures that our WebSocket implementation remains secure and reliable, providing users with a safe and trustworthy experience.
Troubleshooting WebSocket issues is an essential skill for maintaining and optimizing real-time applications. Common problems include connection errors, where clients may fail to connect to the server due to network issues or incorrect configurations. Data transmission issues can also arise, where messages are not sent or received as expected. Debugging these issues requires a thorough understanding of the WebSocket protocol and the ability to analyze network traffic. Tools like browser developer tools or network monitoring software can assist in identifying and resolving these problems. Handling timeouts is another critical aspect of troubleshooting, as inactive connections can lead to resource wastage. Implementing timeout mechanisms and regularly checking connection health can mitigate this issue. Lastly, improving performance involves optimizing message sizes, reducing latency, and ensuring efficient network utilization. By addressing these common WebSocket issues, we can ensure our application remains robust, efficient, and user-friendly. In conclusion, integrating WebSockets with FastAPI provides a powerful and efficient way to build real-time applications. We've explored the fundamentals of WebSockets, how to set up FastAPI for WebSocket support, and the various aspects of managing WebSocket connections. From handling multiple clients to ensuring security and troubleshooting common issues, we've covered a comprehensive range of topics to equip you with the knowledge and skills needed to create dynamic and interactive applications. Real-time communication is an essential component of modern web applications, and mastering these techniques will enable you to enhance user experiences and drive engagement. We encourage you to apply these skills in your projects and continue exploring the possibilities of real-time data exchange. Thank you for joining us on this journey, and we look forward to seeing the innovative applications you create.